the series n equals 1 to infinity root n times x to the n. So our center here, since x isn't subtracting anything, our center here is going to be x equals 0. And then our first step is going to be to determine our radius. So let's start by finding our limit. So L is our limit as n goes to infinity. So I'll start with this root n. So I get root n plus 1 for that n plus 1 term. And I get x to the n plus 1. And I'll divide that by the nth term. So I get a root n here and an x to the n here. Okay. So this will simplify down to just be x. And since I'm taking the limit of n, and there's no x left here, I can actually pull that absolute value of x out in front of my limit. So it no longer has an n in it. I'm left with the limit as n goes to infinity of the square root of n plus 1 over n. Okay, and if I look at these leading terms here, I have n over n, which is 1. So this is going to go to 1. I'm left with the absolute value of x. I'm going to set that to be less than 1, since we know that the ratio test converges if our limit is less than 1. And so if I expand out this this absolute value, I get the inequality -1 less than x less than 1. So this gives me a radius equal to 1 over here. And then my next step is to test my endpoints. Okay, so I'll start with the lower endpoint first, x equals -1, and I'm going to plug that into my series. So that means my series will no longer have an x in it. So I have n equals 1 to infinity of root n, and then I have -1 to the n. Okay, so our strategy here would be to apply the alternating series test. But before I start applying things, writing things down here, I'm going to think in my head really quick, what's the limit? Because usually where the alternating series test fails is at the limit. And I think about the limit of root n, that's just going to infinity. So I know the limit is going to fail. So this thing diverges. I'm going to apply the divergence test here. So I'll take the limit as n goes to infinity of -1 to the n root n. And that does not exist. It's going negative, positive, infinity, back and forth. So this diverges by dt. Okay, so I'm not going to include this -1 endpoint. Okay, and then let's check the other endpoint. So my other endpoint would be this +1. So we'll see if that one gets included or not. And again, I'm going to replace this x here with this +1. So my new series is going to be n equals 1 to infinity. I have a root n. And if I replace this with a +1, I get 1 to the n, which is just 1. Okay, so I don't need to write anything else down. And if I think about this again with the divergence test, this is going to infinity. So this is going to diverge on the divergence test. I'm going to just go ahead and write that down. So this limit as n goes to infinity of root n goes to infinity. So it diverges by dt. And so we're not going to include that endpoint either. And so that means my interval here, my final answer, is just -1 to +1. And I'm going to use those rounded parentheses because I do not include either the -1 nor the +1. Okay, and that'll be our answer there for the values of x that cause this power series to converge. Anything other than those values from -1 to +1 are going to cause that series to diverge.